I am Anil Kumar. Welcome to my series on polynomials. We'll discuss the properties of sum and product of the roots, and based on that, we have four application questions in this particular video to discuss. I'll provide you with a link which will summarize the relation between the sum and product of polynomial roots. The four questions which we are going to discuss are listed here. You can actually pause the video, answer these questions, and then look into my suggestions. You can always email me on the address given here for further information, and also feel free to check our website for the latest videos. Now let's talk about these questions. Question number 1. Solve equation x to the power of 4 plus x cubed minus 3x squared minus x plus 2 equals to 0. We'll actually discuss three different strategies to solve this particular equation. And that will review the concepts about polynomials. So we're looking into three strategies in this case. Question number 2. F of x equals to ax cubed minus 7x squared minus bx plus 24 has linear zeros at x equals to minus 2 and 3. Find the value of AB, that means the product of the coefficient of x cubed and x shown here, and find the third zero. That's your next question. Question number 3. The equation 2x cubed plus px squared plus qx plus 45 equals to 0 has a 0 with multiplicity of 2 at x equals to 3. Find the value of p and q, that is the first thing, and then find the third zero. Question number 4 here is, two zeros of the equation f of x equals to x cubed plus px squared plus qx plus r are at x equals to plus minus a. Find the third zero. So these are the four questions. Let us see how to solve them. Let me also summarize the formulas which we have learned earlier. How are the roots of polynomials related? A polynomial function can be written as an x to the power of n plus an minus 1 x to the power of n minus 2, an minus 2 x n to the power of minus 2, and so on till the constant. Now, depending on the degree of the polynomial, we could actually have sum and product of the roots, right? The sum of the roots can be given by the formula an minus 1 over an with a negative sign. That means it is the ratio of these two coefficients. And the product is what? Product is the ratio of the constant and the leading coefficient, correct? So this product is the ratio of constant to leading coefficient. Okay. With a sign which could be negative or positive depending on the degree, if it is even or odd. Most of our questions are based on cubic equations. Generalizing this equation for cubic, that means just considering the first three roots, we have the set of formulas which are mentioned here. You can always look into these to solve these questions, right? The other things which we are going to learn or utilize here is a part or remainder theorem. We'll also look into synthetic division. Right. So these are the other things which are related to our solution. Let's begin with the question number 1 itself, where we are going to discuss three different strategies. We need to solve this equation, degree 4. We expect 4 solutions, correct? So that means we expect 4 solutions. rather roots. The first strategy which we are going to discuss is, we know that the constant is 2, and therefore the possible rational factors could be plus minus 1 or plus minus 2, right? So we can try one by one all these values. Substituting 1, we can see what do we get. So when I substitute 1, I get 1 plus 1 minus 3 minus 1 plus 2. And that is 0. That means one of the root is at 1 itself. So we get our first root, which is at 1. Now let's substitute minus 1. When I substitute minus 1, I get minus 1 to the power of 4 plus minus 1 cube minus 2 times minus 1 square minus minus 1 square minus 1 plus 2. That is also equal to 0. That means we also get our second root, which is at minus 2. Now, let's substitute minus 2, right? So we got second root at minus 1. Now we'll substitute plus and minus 2 and see, do we have roots at plus and minus 2? Substituting minus 2, I get a 0. That means x3 is minus 2, but substituting 2, I do not get 0. So from here, we definitely get three solutions, which are at x equals to plus minus 1 and minus 2. Correct? So we get these three solutions. Let me write down here. So we get x1 as 1. The second root we found at minus 1, and the third root at minus 2. Now we also learned from the polynomial roots properties that the sum of the roots is equal to the negative ratio of the coefficients of an minus 1 and an, in this case a2 over an, correct? And the product of the roots is the ratio of the constant over the leading coefficient with a negative sign for a cubic equation. Now, since we know this rule, we can now see for degree 4, what is the case? Well, for degree 4, we consider in that case, the sum should be the ratio of these two, correct? Now the ratio of these two is 1. So it should be minus 1, correct? So when you add the roots which we have got, we need to still find the fourth root. We know x1, x2, x3, and x4. We need to find what is the fourth root, correct? Substituting the first three roots and equating it to minus 1, we can solve and find the fourth root as equals to minus 1 plus 2, which is 1. So we get the fourth root x4 as 1. You get the idea, right? So sum of roots is minus ratio of these, right, which is minus 1. So we equated that and found the fourth root without even doing long division. Do you see that part? You could actually check the result with the product of rule. So we check result. When you multiply these four roots, 1 times minus 1 times minus 2 times 1, you do get 2, right? And that clearly indicates that we have the right solution, since the product of four roots should have been the ratio of constant over the leading coefficient, right? So this ratio should have been 2, right? 2 over 1, which is 2, which is the case. And therefore, we can conclude that the fourth root will be at x equals to 1, and we get our answer that the fourth root is at 1. And so at 1, we have two roots. You get the idea. So we utilize the property of sum and product of polynomial roots to solve this particular question, along with the remainder theorem, right? Now let's look into the second strategy. Earlier, we had said that in strategy 1, possible rational factors will be for x equals to plus minus 1 or plus minus 2. When we tried 1, we did get a 0. So we know x1 is 1, first root, and the second root is at minus 1, since that also gives us a 0. So we already have two roots. We have a degree 4 equation. If I divide by the product of these two factors, which are x minus 1 and x plus 1, right, which is x squared minus 1, if I divide by this, I do get a quadratic equation which we can factor. Correct? So it is a combination. Perfect. So now what we are going to do is we'll do synthetic division and then find the other quadratic factor which could lead us to the other two roots, right? So as you know, we have done the synthetic division here. The first root which we are trying to do, we are dividing by x squared minus 1, 1 by 1. So we'll first divide by the factor x minus 1, that is taking 1. Writing the coefficients of our equation, which is given to us right there, x to the power of 4 plus x cubed minus 3x squared minus x plus 2. So the coefficients are 1, 1, minus 3, minus 1, and 2. Bringing down the first term, we get 1, multiplying by 1, writing there, and then adding. When you add this, you get 2, right? And then again repeating the process. So you can do long division if this is not very clear. We do get a factor which is a cubic factor, 1, 2, minus 1, minus 2. Remainder, of course, will be 0, right? So you follow the step of synthetic division. Now let's divide by minus 1. So using minus 1, further applying this property of synthetic division, we get a quadratic factor which is x squared plus x minus 2, right? Those are the coefficients. So as you know, in synthetic division, we write down this coefficients and work with that. So for this, if the synthetic division is not very clear, look into my reference video. So we do get a quadratic factor which is x squared plus x minus 2x, which could be factored as, sum and product is minus 2. So we get x plus 2 times x minus 1. And therefore, we can now write down our function with the 4 factors. The first two we calculated just by substituting 1 and minus 1. And then we divided, got the quadratic which could be factored. So we have x plus 1 times x minus 1 times x plus 2 times x minus 1. You see a double root at x equals to 1. So that gives you multiplicity of 2, or we say order of 2, at x equals to 1. So we have found the 4 roots which are at minus 2, minus 1, 1, and 1. So those are the 4 roots. So this was our strategy 2, where we combined with synthetic division, right? So we did synthetic division. You could do long division also. Perfect. So we combine this with the factor theorem and synthetic division. So we actually have factor theorem plus division. Perfect. Now let's move on and look into another strategy of solving the same question. This time we'll actually factor and then solve. We are given the equation x to the power of 4 plus x cubed minus 3x squared minus x plus 2 equals to 0. Now that seems to be actually a very easy solution, but this solution is very difficult to adopt for most of the equations, right? This was a very simple case and therefore we could easily factor. So what we did was that we split the x squared term as minus 2x squared minus x squared. Once you do that, then you can club the first 3 terms and the next 3 terms to factor. So taking x squared common from the first 3 terms, we get x squared plus x minus 2 as the other factor. And from the last 2, we already have x squared plus x minus 2 if I take minus 1 common. And therefore, we could factor as shown here, x squared plus x minus 2 times x squared minus 1, right? Those remain here, equals to 0. Now these can be factored as shown, x plus 2 times x minus 1 times x squared minus 1, which could be written as x minus 1 times x plus 1. So you do get a factored form straight away from where you could write down your solution, which is x equals to minus 2, minus 1, and 1. The order of that 0 is 2. Well, if you sketch this graph, it is going to look something like this, with the roots at minus 2, minus 1, and a double root at x equals to 1. Is that clear to you? So that is how you could solve question number 1. We have actually taken 3 different strategies, since in different parts of the world we are adopting different methods, right? But now we'll provide the efficient solutions for the other 3. Question number 2. Question number 2a is f of x is ax cubed minus 7x squared minus bx plus 24 has linear zeros at x equals to minus 2 and 3. Find the value of a times b, right? So you need to find the value of a and b and multiply them together to get the value of ab. Now in this particular case, we are already given the zeros. One of them is at minus 2, right? And the other one is at 3. Since these are the zeros, if I substitute the value minus 2 in the given equation, I should get a 0. Substituting, we get an equation, simplify this, and once you simplify this, you get 4a minus b equals to minus 2. Correct? We just substituted x as equals to minus 2. So that gives us our first equation. Now, if I substitute x equals to 3 in the given equation, then I get a 3 cubed minus 7 times 3 squared minus b times 3 plus 24 equals to 0. Simplifying, we do get our second equation. Let me write down this as second equation, which is 9a minus b equals to 13. We have 2 equations with 2 unknowns, a and b. Now you can actually subtract one from the other. So when you subtract these equations, what do you get? You get the value of a, which is a equals to 3. 5a equals to 15, dividing by 5, we get a equals to 3. Substituting this value of a as 3 in one of these equations, I chose the second one, right, which was the first equation here. We find the value of b as 14. So now we know a and b, you multiply them and write down your answer as 42. Is that clear to you? Substituting the values in the equation, you do get the function. Is that clear? Correct? Now actually, you can extend this question. Find the third root. That is our second part, correct? So we already have the values of a and b. We also know that 2 roots are minus 2 and 3. You need to find the third root now, where our solution for the third root is straightforward. Now let's find the third root. We already found the values of the unknowns a and b, and therefore this equation now can be written as f of x equals to 3x cubed minus 7x squared minus 14x plus 24. We are going to utilize the property that the product of the 3 roots is negative ratio of the constant over the leading coefficient. Since we know that the constant is 24 and the leading coefficient is 3 with a negative sign, their product should be negative 8. We know 2 of them, so the third root will be what? Substitute the values, isolate 3 and write down your value. This is the most efficient way of finding the third root when you're already given 2 roots for any cubic equation. So once again, remember this formula. For the polynomials, look into my video whose link is being provided. How do we derive at this formula, correct? So for cubic equation, this will be negative, both will be negative, right? Both the ratios are negative. The product has to be negative value of constant over leading coefficient. And there you go. Here's the graph indicating the solution itself. So those are the given roots at minus 2 and 3, correct? And this is what we found just now, which is 4 over 3. Is that clear to you? That is how you should be solving it. Shortest way. Now let's look into question number 3, which is the equation 2x cubed plus px squared plus qx plus 45 equals to 0 has a 0 with multiplicity of 2 at x equals to 3. Quadratic root at 3, right? Find the value of p and q and find the third 0. So we are already given there are two roots at 3. So looking back into this particular formula and reducing it for the cubic equation, we know that the product is equals to the ratio of constant to the leading coefficient with the negative sign. Both the things are given to us, right? We are given the two roots x1 and x2 as 3 and 3, double root, right? Substituting 3 and 3 for x1 and x2, we can actually isolate x3, right? We have this equation, minus 45 over 2, right? Dividing by 3 times 3 is 9, we get our answer. Third root is at minus 2.5. So we already got the third root, which is at minus 2.5. So we did this part first utilizing the formula which we have derived in another video, whose link is being provided to you here. Now, we know the third root, correct? We also know that the sum of the roots is basically ratio of these two coefficients with a negative sign, which is minus p over 2. Now, since we calculated the third root, which is minus 2.5, 3 plus 3 minus 2.5 should be minus p over 2. Isolate, rearrange, and find the value of p. It comes out to be minus 7. Perfect. So we know minus 7 is the value of p. We know that the root is at 3. That means if I substitute 3 in the equation, in that case, I should get a 0. Substituting 3, we can isolate the value for q. So isolate q and find it as minus 12. And that's all. We could combine with our factor theorem the results and get a result, correct? So that is how you could solve question number 3. You could also utilize another property for the cubic equations right here, which is x1 times x2 plus x2 times x3, where x1, x2, x3 are the roots, right? Times x3 times x1 is equal to the, in this case, q over 2. From here also, directly, since we know the values of x1, x2, and x3, we could calculate the value of q. That could be the shortest way of doing it. Is that clear to you? So try this out and verify that this is the correct answer. Now let's look into the fourth example, which is two zeros of the equation f of x equals to x cubed plus px squared plus qx plus r are at x equals to plus minus a. One zero at a, the other one is at minus a, right? So they are of opposite sign, same value. You need to find the third zero. So again, a cubic equation is given to us, so we'll reduce the formula for the product and sum of the roots, right? So this is basically an application on sum and product of polynomial roots, and that is actually the most efficient way of calculating the roots or working with the roots. We're already given x1 is a, x2 is minus a. So we need to find what x3 is. Let it be equal to b. So in that case, the function could be written as x minus a times x plus a times x minus b. Well, which is x squared minus a squared times x minus b, since the difference, sum and difference, is difference of squares. Now you can expand and simplify. You get x cubed minus bx squared minus a squared x plus a squared b. Compare the coefficients with the given equation. Now the given equation is x cubed plus px squared plus qx plus r. Now let's compare the coefficients. So comparing the coefficients, we can write p is equals to minus b, and that is the first. The second one, which I wrote here, is q is equal to what? Minus a squared, correct? Just compare. And what is r equals to? Well, the value of r is equal to a squared b. So the value of r is written as a squared b. So we just compared and we wrote the coefficient in terms of the roots, right? A and b are the roots. So from here, you can clearly see, since r is equals to a square b, r is actually p times q, right? So if you multiply these two, p and q, you do get a square b, right? So we can derive that r is equals to p times q. So I substitute this value of r as p times q in the given equation, which was xq plus px squared plus qx plus pq. Now, we need to figure out what is the root. Well, we have already got the answer for the root, right? Find the third root. Third root is b, correct? Third root is b. You see this? This is the third root. You can say x3, correct? X3 is p. Perfect. So this is verification. Third root is equal to minus p, right? Not p, minus p, right? Since p is minus b. So third root is minus p. So we are just checking. When you substitute minus p in this given equation, you get minus pq plus p times minus p squared plus q times minus p plus pq, which is minus pq plus pq minus pq plus pq, which is 0. And therefore, we do get 0, and that verifies that the third root is at minus p. You get the answer. So we have this answer here. Third root is, I'm writing it at x3, which is at minus p. Is that clear to you? So that is how we're going to do it. So I hope with this, you understand how do we solve such questions. We did utilize the formulas which were developed earlier. We also utilized the factor theorem and Rolle's rational theorem. In selecting the roots along with the formulas which we had derived earlier, right? And we used all this to solve some brilliant questions based on sum and product of polynomials. I hope this makes sense to you. Please feel free to write a comment, share your views, and if you really like and subscribe to my videos, that'll be great. Also, you can send your queries on the email given here for further uh, knowledge on the same. Thanks for your time and all the best.